Hello, my name is Victor Ring. I am the code instructor for JCR Productions and wanted to cover for you a few of the basic fundamentals and some of the theory of electricity and a few of the terms and some of the vocabulary you're going to be hearing. We are very aware that in the electrical industry, there are many facets. You may work in delivery, you may work in construction of it, you could work in the service industry. There are many aspects in the service industry. You may even come from some of the other associated trades that are interconnected. But we want to be able to provide you with a general knowledge that will assist you in preparing for your exam prep seminar. I want to start with some of the basics, and we'll just talk about them for a few minutes. The first one are your basic terms. The basic terms are 4 words: voltage, ampacity, ohms, and wattage. First of all, voltage is that electromotive force that is the flow of the excited electrons. Second is our ampacity. That is the current, or that is the force that actually causes equipment to operate. Next, when we combine the flow of those, we have a result that is normal, just like this. You rub your hands together, you have a moving force. There's a heat associated with that. We refer to that as ohms or resistance. And lastly is wattage. That's power. When a manufacturer builds a piece of equipment, they add all the minor totals up and they assign a wattage. In other words, that's the total amount of energy of all the processes that electricity will perform. And it will give a value to that piece of equipment. It requires 1,500 watts. But in the electrical community, when we install equipment, we convert that to ampacity. So we'll take and use a formula to do that. So what we find is there are 12 Ohm's laws, but the National Electrical Code only utilizes one in calculation method because they have found it fits all categories. So it is watts divided by voltage equals ampacity. Now we can use it in the other direction. We can go amps times volts equals watts. But this is our basic formula. So from there, the first key thought we need to apply is that when we began to do the calculation process using these 4 components, we must make some adjustments. And those adjustments are based on factors. And that's what we call them. They're factors. Those factors are, the first one, continuous duty. Now, what we describe as continuous duty is when we're going to run something more than 3 hours. Is your refrigerator on 24 hours a day? You betcha. And you want it to be that way. So therefore, it's a continuous duty device. So when we would size that branch circuit for that refrigerator, we would make sure that the working requirement of the refrigerator was then enhanced by a number or increased, and that number is 1.25 or 125%. So that is, in definition, our description of continuous duty. If it's going to run 3 hours or more, we're going to increase the size of that requirement by 125%. The second one is a demand factor or a deration. That deration or the demand is one and the same. And bottom line, what we find is that when you go into an alternating current system, not everything's on. Not everything's run all the time. You don't run everything in your house at the same time. You may only have the TV on sometimes. So we are able to apply a demand factor or a deration on that known value because we know it's not going to operate 100% of the time. The third one is a temperature adjustment or a correction factor. This happens based on that process I told you about of that resistance. We know that within our systems, alternating current is always going to have a certain amount of heat. That's why all of our equipment has performance values based on heat. And so what we have to do is say, perfect example, we have a piece of equipment we want to install in a room, and that room happens to be 125 degrees. It is going to reduce the ability of our already built-in factors or performance features in our system to provide for that normal amount of heat. So we've got to correct for that. That's why we have to adjust for temperature. So we're going to be covering some of that in class. So we want you to be aware of that, because now that won't be an abstract thought. You'll understand what we're trying to do. If it gets too hot in there,